Good morning to everybody, to all grade 10 students. Good morning to all of you. So for today's lesson, we will discuss about permutations and probability. Let's start. Question number 1, what are the probabilities for rolling up one dice? A standard die has 6 sides printed with little dots numbering 1, 2, 3, 4, 5, and 6. Since there are 6 possible outcomes, the probability of obtaining any side of the die is 1 over 6. The probability of rolling a number 1 is 1 over 6. The probability of rolling a number 2 is 1 over 6. This is the continuation of question number 1. What are the probabilities for rolling one dice? To determine the probability of rolling any one of the numbers on the die, we divide the event frequency, which is equals to 1, by the size of the sample space, 6, resulting in a probability of 1 over 6. So the answer here is 1 over 6. Question number 2, what are the probabilities for rolling 2 dice? So in this case, we will use the probability table. The possible outcomes of rolling 2 dice are represented in the table below. Note that the number of total possible outcomes is equal to the sample space of the first die, which is equal to 6, multiplied by the sample space of the second die, 6, which is equal to 36. So here is the probability table. As you will see, the numbers vertically from 1 to 6 is the first die. Then the numbers 1 to 6 horizontally is the second die. So number of total possible outcomes, or simply we call it sample space. So if we will count from 1, 1, 1, 2, 1, 3, 1, 4 until 6, 6, so that is equivalent to 36. 3 or more dice. The same principle applies if we are working on problems involving 3 dice. We multiply and see that there are 6 times 6 times 6 equals to 116 possible outcomes. For 2 dice, there are 6 squared possible outcomes. For 3 dice, there are 6 cubed or 6 raised to the third power possible outcomes. Then in general, if we roll n dice, so the formula that you are going to use is 6 raised to n possible outcomes. Let's try this example. 2 6-sided dice are rolled. What is the probability that the sum of the 2 dice is 7? Using the probability table, 6 plus 1 equals 7, 7 plus 2 equals 7, 4 plus 3 is 7, 3 plus 4, 7, 2 plus 5, 7, 1 plus 6 equals 7. So as you will notice that all of these combinations, the sum is equal to 7. So to find the answer, this formula, P sum of 2 dice is 7 equals 6 over 36 equals 1 over 6. So the numerator 6 represent the frequency, and the denominator 36 represent the sample space. The number of total possible outcomes remains 36. Again, we find the probability by dividing the event frequency 6 by the size of the sample space 36, resulting in a probability of 1 over 6. So in this question, so the answer is equals to 1 over 6. Number 2 examples. Two six-sided dice are rolled. What is the probability that the sum of the two dice is 3? Here is the probability table. So we have now 2 plus 1 equals 3, 1 plus 2 equals 3. Then the rest, the sum is not equals to 3. So therefore, to find the answer here, we have now 1 over 18. To find the probability that the sum of the two dice is 3, we can divide the event frequency 2 by the size of the sample space, 36, resulting in a probability of 1 over 18. P sum of the two dice is 3 is equals to 2 over 36, then equals to 1 over 18. How about this? Two six-sided dice are rolled. What is the probability that the numbers on the dice are different? Here is the probability table. So the colored numbers or cells, the numbers different. Then so just count it as your numerator now. So P numbers on the dice are different, equals 30 over 36 is equals to 5 over 6. There are only 6 of them, and once we cross them out, we have the remaining cells in which the numbers on the dice are different. We can take the number of combinations, 30, and divide it by the size of the sample space, 36, resulting in a probability of 5 over 6. Next is calculating the number of possible outcomes of a coin toss. If we have one coin, there are two possible outcomes, which is head, tail. Two coins, 4 outcomes, head, 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 tail, tail, head, and tail, tail. 3 coins, 8 possible outcomes. 4 coins, 16 possible outcomes. So permutation is an arrangement of objects in a definite order. So here's the formula. Permutations P and R equals n factorial over quantity n minus r factorial. Note, the number of permutations of n things taken are at a time. For example, the number of ways third and fourth position can be awarded to 10 members is given by P 10 2 equals 10 factorial over 10 minus 2 factorial equals 10 factorial over 8 factorial is equals to 10 times 9 times 8 factorial divided by 8 factorial is equals to 10 times 9 is equals to 90. How about this, question number 2? The racing club organizes a race in which 6 cars A, B, C, D, E, and F are joined. How many possible race results if there are no ties? The letter B, in how many ways can the first two positions be filled if there are no ties? So let's show the solution. For letter A, P66 equals 6 factorial over 6 minus 6 factorial is equals to 6 factorial over 0 factorial. By the way, 0 factorial is equals to positive 1. Then 6 factorial over 1 is equals to 6 times 5 times 4 times 3 times 2 times 1. So the answer is equals to 730. In how many ways can the first two positions be filled if there are no ties? So here's the solution. P equals 6 factorial over 6 minus 2 factorial equals 6 factorial over 4 factorial is equals to 6 times 5 times 4 factorial divided by 4 factorial is equals to 6 times 5. Then the answer is equals to 30. Permutations means the selections of objects where the order of selection matters. In other words, it is the arrangement of R objects taken out of N objects. The formula for permutations is NPR equals n factorial divided by n. Another formula that you can use is P equals n factorial over A factorial, B factorial, C factorial ellipsis. The number of permutations of n things where A things are alike, B things are alike, and C things are alike, and so forth is P equals n factorial divided by A factorial, B factorial, C factorial. Let's try this example. Find the number of distinguishable permutations of the letters in each word. Letter A, mathematics. Letter B, algebra. For mathematics, there are 2M, 2A, then 2T. So they are alike. Solutions, P equals 11 factorial. 11 because there are 11 letters in mathematics. Then over 2 factorial times 2 factorial times 2 factorial. Then is equals to 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 2 times 1 times 2 times 1 times 2 times 1. So the answer is 39,916,800 divided by 8 is equals to 4,989,600. How about the word is algebra? So we have now 7 factorial, then only we have 2A, so that's why the denominator is 2 factorial. Then 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 2 times 1. So it's equals to 7 times 6 times 5 times 4 times 3 is equals to 2,720. Try to solve this in your notebook, practice exercises. Find the number of distinguishable permutations of the letters in each word. So number 1 is statistics, number 2 probability, number 3 combinations, 4 permutations, and number 5 substitutions. Okay guys, that's all for today's meeting. I hope you understand the lesson. So have a nice day. Bye-bye. Keep safe. Bye.